Sean, where are we at?
We're at the Nashville show trying to demonstrate some of our latest and greatest equipment here.
It's enabling technologies, right? And
Yeah.
then we can sit and rethink that concept that was there is now achievable.
So it's like a CNC machine on steroids, but for logs.
Pretty much, yeah.
It just gives it that last little fine touch of perfect zero line. That's all it's doing.
Sure.
At least 2 decimal places of a degree.
This is revolutionary, I
It's
believe.
totally revolutionary, yes.
The philosophy was mechanically simple, software complex.
No matter what the shape the log is.
That's incredible.
You have only one way to run it. Took the mechanical side and advanced it to what technology is today.
That's right. That is what RPM does. We don't do it like everyone else. We do it different, but not just to be different, but to be better.
Sean, why is there a log above my head?
This is a part of our ProDOG system that we've bring into the show this year of the new stuff that we've kind of came up with. And what this does is actually position the log into the ProDOG line. So this is kind of like the last piece before the ProDOG grabs it and sends it down the hole to get canted and double profiled. So this just brings a lot of accuracy to this style of primary breakdown. So it comes down through an infeed system. And then once it's into the infeed and gets a scan and gets all the data, this is the last piece that positions it.
Okay.
Yeah.
So the log that we see here came through an infeed.
Mm-hmm. It got scanned, it got even-ended, it got pre-positioned and for rotation. And then this grabs it from that. And once it gets that scan, it actually positions it left, right, up, down, and at plus or minus 30 degrees to get it exactly in the exact spot. And what I like to always talk about this is what makes it so cool is most systems, you scan it and you shove it down a hole and you try to position it the best you can. But, you know, logs vary so much that there's always an imperfection there.
That's right.
But with this, once that thing is clamped, it's part of the tool.
Yeah.
It is part of the machinery.
Those jaws bite into it.
Bite into it. Now it becomes, and then we get one last little scan and say, oh, it moved 0.45 degrees off here, and I can just position it the last little bit because it's part of the tool,
It's basically a CNC machine.
It's a CNC machine. That log is part of the equipment, right? So then the accuracy just goes through the roof, and now when we grab it, we cut.
This is revolutionary, I believe.
It's totally revolutionary, yes.
What's the inspiration here, and what did you guys do?
We both came from Sierra Pacific originally, which Sierra Pacific was very in-dog heavy. Yeah. And so we were involved in building this equipment with the help of Ted Foster back in the day.
Wow.
And so it's something that we've kind of been thinking about, and we've always thought that it would be the future. Once technology caught up with it, it's the future of primary breakdown.
This is incredible.
Yeah.
Can you share a couple ideas or thoughts of the ideas of the concepts behind what are we seeing here? Why is there a log above my head?
Yeah, so the whole concept of this is just being able to position the log and rotate it perfect, exactly where the optimizer wants it. That's kind of been the limitation over the years, is where you can actually position that log. Because you always get the perfect solution from the optimizer,
sure,
but it's the execution of it that's always been falling short. But what we have here, we can literally put it anywhere. Like if you tell it to go 5 degrees, it'll go 5 degrees exactly.
So it's like a CNC machine on steroids, but for logs.
Pretty much, yeah.
And what's the accuracy? Just give me some kind of information about, because you guys are really the brains behind it. Like,
well, with our other machines, like our gang, the following error is like at the 5th decimal place as far as following error that we've seen with that stuff.
Yeah, I mean, the rotation on this is, you know, into the, I don't know, at least 2 decimal places of a degree, right? So yeah, it's totally, and once it's part of the tool, you're going to get it every time. So, because your scanner's looking at it right at that, after it's actually clamped.
Wait, does this have to do with the CT scanning system, or that's separate?
It integrates into it.
Can you explain how? What is that?
Well, the big thing you get with this is you actually get everything the CT has to offer with this, because we can put it exactly where the CT wants it.
Okay.
The log doesn't have to be horns down, doesn't have to be horns up. It can be anywhere, because we're not worried about stability on a chain. We just put it wherever it needs to go, and then the dogs grab it and it stays in that position, no matter what shape the log is.
That's incredible.
Yeah, CT scanners have been around for a little while, but really they haven't been used at their full potential, because now once the CT scan says, okay, you need to position the log right here.
Yeah.
Well, sharp chains have to have horns down. They can only be so far off, or they can't run it.
Down, and you're only plus or minus what?
So you're not getting the benefit out of the CT scan that everybody's, So this actually pulls, it brings the CT scan and makes it a great marriage, because now we have the machine that can do a full 360. Anywhere they want it, we can position it. And
so it's a banana shape, but you can do the banana in any direction.
we can do anything. Yeah, we can position that log anywhere it wants. Let the CT scan do its job. Where the sharp chain line, you can't. You have only one way to run it.
Yeah,
Horns down, is that right?
That's right.
both an angle and offset. Like, you can offset the whole solution of a log off to where it's hanging off the side. Whereas on a chain, you have to have all of the mass pretty much over the center of the chain, where we don't have that limitation here.
Or maybe you want a center cant and a side cant right down the middle of the log. You can't run a saw line down a sharp chain down the middle, right?
No.
Yeah, where this you can.
Seriously?
Yeah, you can put two cants on the side. Let's say 4 inches high that day. Well, you can get two 4-inch cants out of there. Yeah, right down the middle of it.
Wow.
Yeah.
So what happens next? How are you actually gonna? Now you've CT scanned it. You've brought it down. You were saying the infeed, right? And then you've got some scanners up there. What are those scanners for?
Those scanners, they do two things. The first scanner, it builds a 3D model of the log, and then it identifies that back to the CT scanner to pull the solution from the log of the scan solutions over there.
Yes.
Identifies it back to here and says, okay, this is log number 24, whatever. So then we know that we have that log, right?
Yep.
That's the first one. The second one is for our pre-rotation and position correction zone. So the log starts over here. We take it from the log deck into here. This first zone, this is the even ending rolls.
Okay.
So this even ends the log, gets it to a 0 log line.
Yeah.
And then it lifts up from here and rolls into this zone, which this is our scan zone.
Okay.
Our first scan zone.
Yeah.
And as the log rolls in, that scanner is actually starting to already scan it before it's in that scan zone.
Oh.
And these chain turners only turn it enough to get the full 360-degree image of it.
Yeah.
And then from that, we build a 3D model of the log.
Yeah.
And we pull that back from the CT scanner to identify it to the solution that the CT scanner came up with.
I gotcha.
Is it's starting to scan as soon as it rolls in? So sometimes, if it gets a good vision of it, this thing might now have to rotate but 30, 40 degrees. All it's doing is the cleanup of what it didn't see already.
Understood.
We need to see all the way around it. This kind of cleans it up. So
Understood. Just for identification, because you already have the model built ahead of time.
It's for both. It is for identification, but say the customer doesn't have a CT scanner, or the CT's down for whatever reason, or it can't match the solution, we can still do a geometric optimization in this spot right here.
Super smart. You don't want extra downtime because of that. Yeah.
Exactly.
Understood.
Right.
So what happens next?
So from here, it indexes up with these lifting arms into this first catch and loader.
Yeah.
This is just an indexing spot, a pre-position. Then it indexes over to the second one. But over here on this second one, this catch and loader actually even ends. That whole thing, all of the orange stuff there, moves 5 inches over. So this is the even ending catch and loader. So when the log rolls in through here, it might still want to move a little bit this way away from our 0 lumber line. So when it comes into here, this catch and loader moves up to 5 inches over to make sure that the log's at that 0 lumber line. Because with end doggers, you want to have a consistent 0 lumber line for cycle time, so that 0 dog always comes to the same spot. Dogs it for quicker cycles.
Okay. So this is a whole deal. This whole deal moves over.
All this orange stuff right here all slides over.
it just gives it that last little fine touch of perfect 0 line. That's all it's doing.
Sure.
Yeah. When the dog arm comes and snaps down, you don't want it to hit the log, or you don't want it to have to sit there and slowly work into it. We want to know right where it's at so it's fast.
Understood.
That's right.
And then what happens?
So from here we have this is called our pre-rotation module. It does all of our pre-rotation and position correction. So this second scanner over here is looking in this zone, And these arms right now, they're shown all the way up. That's to be able to back out if there's a double load or if they see something they don't like, they can back the logs back up into the catch and loader. They'll normally be in that down position that those two center ones are in.
Yeah, you can see this one
Yeah,
here.
I see that. Okay.
So the log rolls down, scanner's still looking at it, and the servo motors will turn the log to pre-rotate it to a window of, plus or minus 5 degrees of where we actually want it to be.
Yep.
Just so, because we still have plus or minus 30 on the turning yokes. Do that final bit.
Yeah.
Yeah, so this is going to get it close, but that's going to finish it off to the once it becomes part of the tool, like I keep saying, that's when it's going to finish it off perfectly.
I love it.
Yeah.
Yeah, those turning yokes actually sit underneath of all of this.
Okay, that's where the next question. Where is that?
Yeah, these pads here sit on top of those pads. So this whole unit here is on top of that.
Oh, okay, now it makes sense.
Yeah, those turning yokes, they'll charge. They go from here about 34 inches over to here every single time to take it to the center line of the end auger.
And right here is where it's coming down.
This is the center line here?
Yes.
Oh, I got you.
That's right.
So the yoke, can you just show the motion, grabs it, does the pinch?
Yeah, it'll do the clamp. It comes up, clamps. These arms go down out of the way. We take our last picture with the scanner to see how much.
This on the tool. This is now part of the tool.
Correct.
Last picture.
Takes the last
adjustment.
It'll take the final. It'll make the final adjustment as it moves over. So it'll lift, tilt, slew, skew, and rotate as it goes over, and then it'll get dogged from there. Get put in that final position from the optimizer.
Jeez, man. So Richard, the guys said that to control all the steel and the scanners and everything, we need to do controls. Nick was mentioning that you're the guy that's kind of helping spearhead that. Can you share a little bit about how do you put all this metal to use and what actually happens behind the scenes with the software? You had some really cool things you shared with me yesterday.
Yeah.
I was thinking that this guy was Steve Jobs the other day, but what were those lines? Can you share some of those thought processes and the philosophy behind the design?
Right. So I've been in this business for 20 some odd years. My partners before that, 30 years. So a lot of expertise on how the process, how the machines in general in sawmilling work.
Yeah.
And that's where it all starts. You have to know what the end result is of taking a log and turning it into lumber.
Yes.
Right?
Yeah.
So that's what we do. First thing we have to teach our young people is around what are we doing here? This isn't just programming, right? It's you have to be a process expert. Once you get there, now we get some smart mechanical engineers and we collaborate and we design equipment that is revolutionary, right?
Absolutely.
That is what RPM does. We don't do it like everyone else. We do it different, but not just to be different, but to be better. Solve the industry's problems, right, with new machinery and equipment. So, Sean and I, when we were starting RPM 7 years ago now, we sat down and said, the philosophy was mechanically simple, software complex. Software doesn't wear. What I mean is that software doesn't wear out.
That's right. Okay.
Day to day to day to day, it just keeps running, right? Bearings wear out.
They do.
Things. And one of the things that happens often is mechanically you try and solve problems.
Yes.
Traditionally, but technology now with computing power, motion control, all these things, you can now do things that make the mechanics simple.
Yes.
And move the complexity where it doesn't wear out.
That's the Steve Jobs moment.
There you go.
If you ask me.
So that's everything you look at from our Pro Saw. Now what we're doing here, we try and do things more complex in software. And what that does for our customers, we've had this comment on our Pro Saw. It's like, I know how all this stuff works mechanically. We got bearings, we got lube, but there's no real complex, fancy, even the wiring and things like that. We make it all so that it's maintainable and by the average, millwright or sawmill worker, right? That's the whole game.
That's a beautiful philosophy, if you ask me. It's incredible.
But with the control side being what it is, it brings down our maintenance it's required. It brings, it makes things last longer on the mechanical side where you're not beating things around like we used to in the day. So what Richard's saying is we have to design together as a team to make all that happen, to where let the controls do as much work as we can, to where the mechanical side can get easier and last longer, stays more robust. I mean, you look at the old machines where air cylinders beating on things, there was a lot of wearing components. We don't have that anymore.
Yeah.
Those days are over.
Right. And the other thing that goes with that is we focus on total cost of ownership of our equipment, right? We don't try and be cheap. We don't try and, we look at anything that Nick and Sean have done mechanically is built to last, right? And there is a premium to pay for that. But to the air cylinder point, right? We have things here that you can do and actuate with air. But then total cost of ownership over the life of that machine, consuming air rather than electricity, all these things are more expensive when you factor that all in. So that is the other part of our, we build it heavy, we build it to last.
I love the philosophy.
Yep.
What are the main challenges? If you could summarize everything we are looking at here and the Two Rivers 2.0 and Roy Geiger, he's excited about it. What's so revolutionary about it if I'm maybe on the, give me the 30,000 view.
There's nothing new here.
Okay.
Right? End dogging's been done.
Yeah.
For a long, long time.
Right.
So what has caught up and what are we doing that's different?
Right.
Nick and Sean both understand their previous life, built a lot of these machines. We know, just like we did with the ProSaw, all the problems that were there that needed to be solved.
Correct.
Right? So we focus on that. Technology, the application of new technologies, servo motors, these beautiful designs and these gears and all this stuff we have here solved the problems of the old machines. So the concept, we've got these new scanners, we've got all these things. It's enabling technologies, right? And then we can sit and rethink that concept that was there is now achievable because of technology. And that's what we do. So we have a new product here. It's nothing different than hasn't been done, except now the enabling technologies are going to solve maintenance issues, accuracy, right? And
we just took the mechanical side and advanced it to what technology is today.
That's right.
Guys, I think you're doing a phenomenal job. I'm a strong supporter, and I want the whole wood world to know that these are my friends, and they're changing the wood world, and let's get that message out there to the whole globe, wood world. Thank you, guys.
Thank you.
Thank you.
Thank you for the
Appreciate
tour.
it.
Thanks, man.
Thank you. Thank you.